Recommender system. I divided my presentation into four main parts. First, what is recommender system and their application in e-commerce website. Second, utility magic. Third, content-based recommender system. Lastly, collaborative filtering recommender system. Let's move on to the first part. What is recommender system and their application in e-commerce website? Recommender system is the most popular application of data science today. It's using to predict the rating or reference that a user could give to an item. Almost every major tech company has applied them in some form or the other. For example, Amazon uses to suggest products to customers. YouTube uses to decide which video to play next on autoplay. Facebook also uses to recommend products for efforts and recommend people to people. In general, recommender system can be classified into three types. First, simple recommenders. It offers generalized recommendation to every user based on the popularity and/or trend. For example, top selling on Amazon. Content-based recommender suggests similar items based on a particular item. Third, collaborative filtering engines. These systems try to predict the rating or reference that a user could give an item based on bad rating and reference of other users. That's the example of Amazon recommender system. Frequently bought together, and customer who bought the item also bought. Let's move on to the second part, utility magic. In the recommendation system application, there are two classes of entity, user and item. User have reference for certain item, and the reference must be teased out of the data. The data is represented as utility magic. We assume that the magic is sparse, meaning that most entries are unknown, and we have no information about the user reference for this item. The goal of recommendation system is to predict the blanks in the utility magic. That's an example of utility magic. Figure 1 represents the utility magic rating of movie on a 1 to 5 scale. For example, the user A gives the item HP1 the rating 4 out of 5. Or for example, the user B gives rating for item HP2 5 out of 5. Let's move on the third part, content-based recommender system. First, item profile. The item profile is the main part of the content-based recommendation system. For each item, we create an item profile. A profile is a set of features, for example, movie, like author, title, actor, director, or image, video is a metadata and text of people, a set of friends. The profile is a format of feature vector. This is a sample of feature vector. We can see that some songs like Mưa nửa đêm, Cỏ úa is in type of bolero song, and Con cò bé bé or Em yêu trường em is in type of children song. And you can see that in the right hand side column, item feature vector x1 equals 09900. 000. Let's consider the item model name. The user A give rating for model name 5 point, user B 5 point, user E 1 point, and the item feature vector x1 equal 0.99 and 002. It means that the item 1 is rate in it rate in the bolero song more than the children's song. B. Building a log function. The problem of finding a model theta I for each user can be considered as a regression problem in the case of rating a range of values. In the example, I use linear regression with regularization regression. Log function regression is defined in table below. Where E has n is subvector of Y, which is built by adjusting the order component different from question mark in column n. X hat n is submatrix of feature matrix X, which is created by adjusting the row corresponding to the item that was rated by the user n. En is the column vector which contains Sn element. Move on. Part C. Example of log function. From figure 2, we can get feature matrix for item, which n equal 5, y5 equal 1, question mark 4, question mark. We can infer that r5 equal 1, 0, 0, 1, 0 because user E just rate item 1 and 4, so that f5 equal 2, and we apply the log function in and calculate this log function. We have it have 5 equals 0.99, 0.02, 0.01, 0.99. E has 5 equal 1, 4. E5 equal 1, 1. And we substitute it in the log function. Demo on the data movie lane 100. Easier data contain many files. For example, u.data contain rating of 943 users for 100,682 movie. US by US test contain data for changing u.user contain information of user including ID, age, sex, occupation, zip code. In this example, I just use the ID to distinguish the user. U-genre contain 19 types of film, including unknown, action, adventure, animation, children, comedy, blah blah blah. U item contain information of a film. It's here for first row of U item. You can see that, for example, the Toy Story 1995, and the link, and the type of the film is if the 0 is not in a type of film and 1 is in type of film. First, we import the library Panda TF-ID transformer, rich and linear model, and NumPy. Reading user file. I name the user column the user ID, age, set, occupation, and the zip code. And after that, I read the file CSV and assign it to the user. And I bring to the screen the number of user and the first file user information. Reading the rating file, I also name the rating column user ID, movie ID, rating, and a unique timestamp. I read the UR by and assign it in rating by and UR test in rating test, and change it into array by rating by dot value, rating test dot value, and string number of chaining ray and number of test ray. Reading item file, I name the item file the movie ID, movie title, release date, video release date, and so on. And also read the file and assign to item and bring the number of item. Because we based on genre of movie to build a file, so we just get 19 binary value at the end of each row. So we create x0 equal item dot value the array, and exchange count equal x0 minus 19. That means that we get the value of array from the bottom array. Next, we build feature vector for each item based on genre matrix and feature TF IDF. In the example, I use sklearn library to calculate. Then with each user, we need to find the movie that the user has rated and value of the rating. Then with each user, we need to find the movie that user has rated and value of the rating. The function get item rated by user. In each line of array matrix, we have data for user ID, item ID, rating score, timestamp, but we just care about the first two values. So we return the item IDs and score. First, we assign the array matrix into I. Is the item index rated by user ID. We need to plus 1 to user ID since in the array matrix ID start from 1, while index in Python start from 0. After that, we return the item IDs score. Then we find in the grid direction parameter for user, calculate D, calculate W, calculate B, and we look on the array and calculate each hash CLF, each hash score, and coefficient in the set. After calculate on parameter W and B, we predict the rating for each item E hat by TF-IDF dot W plus B. This is example with a user having ID equal 10. We assign N equal 10 and ID score get item rated by user rated and E hat and IDF. We ring the E hat IDF and ring the rated movie ID and the true rating and the predicted rating. To evaluate the model, we use root mean square error, stand for RMSE. The formula to calculate RMSE is given IMSE equals square root of sigma predicted minus actual square over n. This is source code for calculate root mean square of contemplated remainder system. We can see that the output is MSE equal 1.07032. Lastly, neighborhood-based collaborative filtering. A similarity function. Figure 3 given the utility matrix based on user rate for item. For figure 3, we can easily see that user U0 is similar with user U1. And we can get that user U0 multiply item I2 because user U1 also like item I2. There are some question marks in utility matrix, and the mission is finding own value for question mark and giving the recommendation for user. This is an example how the user collaborative filtering work. First, we have the original utility matrix Y with many question marks, and we calculate the mean value of user rating. For example, we calculate the mean value for the user U0 by take the sum of own rating and divide it by the number of rating. For example, we take 5 plus 4 plus 2 plus 2 and divide it by 4 and we get 3.25, and we do it with own user, we get the mean value. After that, we normalize utility matrix E Y by take the rating value minus the mean value. For example, we take 5 minus 3.25 and we get 1.75, and we do and the rating, if unknown, we take the 0. After that, we calculate the user similarity matrix by formula similarity equal cos theta equal A dot B over AB. For and the similarity between one user is equal 1. And for example, we calculate the similarity between U0 and U1. We take 1.75 multiplied by 2.25 plus 1.05 multiplied 0.75 plus 1.05 multiplied 2.75 over square root of 1.75 square plus 0.05 square plus blah blah blah, and multiply by square root of 2.25 square plus 1.25 square, and do that. And after that, we have the user similarity matrix. After that, we predict, we calculate the we calculate the question mark value, the unknown value, by predicting. For example, we want to calculate the value in there. We consider that this is the item I1. The item I1 is rated by the user U0, U3, and U5, and the corresponding similarity is 0.83 minus 0.40 and minus 0.23, and the most similar user U1 E1 equal U0 U5 with normalized rating 0.75 and 0.5. We can calculate E has E1 U1 equal 0.83 multiplied by 0.75 plus minus 0.23 multiplied by 0.5 over 0.83 plus absolute of 0.23 and equal 0.48. After fulfill all the unknown value on the utility matrix, we return the original utility matrix by take the sum of this value and the mean value, and we get the utility matrix with all unknown value is fulfilled. And the item collaborative filtering, we do the same thing with the user item collaborative. We just first we just calculate the mean value of item from 0 to 4, and after that we normalize the utility matrix, and we calculate the similarity between the item, and we predict on the value of unknown value, and we return the original utility matrix. Demo on Python. Given the data in the table, this is data sample for demo. The order of 3 columns is user ID, item ID, and rating. We can transpose the matrix to do item collaborative by it change the position of the first column and the second column. The order of utility matrix will become item ID, user ID, and rating. Class CF. First, we create a constructor init UUCF equal 1 if we use user collaborative filtering, and UUCF equal 0 if we use item collaborative filtering. K is the number of neighbor points. This function and E bar this function is similarity, and E bar y bar data equal none, and n user and n item is the number of user and item, and remember that we must plus 1 since ID start from 0. The function add. When having a new data, updating utility matrix by adding new row at the end of utility matrix. The function normalize y. The user equals cell dot y data is 0. We take the first column of the y data, means that we take all the user, and with cell mu equal np0 cell n user, and we take a for group and tend to and normalize on the value of the magic. The function refresh is normalized data and calculate similarity magic again after some field rating it, and the function fit. The function to predict the rating of user U for item I after normalize. Step 1, you find all the user who rated I. Step 2, user rated I is passed in the magic. Step 3, find similarity between the current user and other user who already rated. We take similarity equal S U user rate Y. Step 4, we find the k-most similarity user by sorting and the corresponding similarity level. If no line, we can and as that we return the predict value. The function recommend, we return the recommend item. In ring recommendation, we ring if you use CF equal 1 or equal 2, if it equal 1, we bring the recommend item for user, and if it equal 0, we recommend item to user. And this is the output of recommendation for user collaborative filtering, and this is the output of item collaborative filtering. And after that, we calculate the error, apply its algorithm into the data movement, and calculate this root mean square. We can see that the error in item collaborative filtering is less than user collaborative filtering, and the error in neighborhood-based collaborative filtering is less than content-based system. Reference: machine learning cơ bản.com